So there are several reasons why you want to run a job. Think of a job as a container that will be run a single time for a one-off task. That's for the first glance a good mental model. So, well, there's always more than one way to do it, and I'm not suggesting these are best practices, but you could, for example, run jobs for performant database migration, although you could also argue that this could also be done differently, for example, in an init container, as it pretty much depends on how complicated your database migration is, how significant or how big the impact on your application is. So I'm not suggesting that this is the only way. So database migrations could be a reason. Administrative one-off tasks seem to be a good match. Analytical workflows seem to be suitable. And as we will also see, the job concept will allow you to run containers in sequence as well as in parallel. So it's you could even say it's well, let's say the foundation of what could be a workflow engine. And in fact, there are workflow engines running on top of that concept. In particular, there's the Argo project, where there's the workflow engine, Argo Workflows, which sits on top of that functionality, I think. Yeah, it could also be that they're using init containers. Whatever. So what is a job? A job is a utility to execute short-lived workloads by starting pods up until successful completion. So that's pretty straightforward. And let's not make this longer than necessary and give it a try. So, this command runs as a busybox image. It's interactive, so we could do something like hello world 1. You can see it has echoed. And you can also see that we can retrieve the logs of the busybox we've just executed. Now, we can also run a simple one-off task based on the busybox. And then see that no job has been created, because what it did, it has been creating a pod instead, not a job. So you can see that our simple one-off task has been executed as a container. So pretty much the same effect. All right. So now we're creating a job description. As always with Kubernetes, or as most of the times, we're creating a specification for such a job. We are choosing the YAML format to do so. File will be called simple job. So API version, batch version 1, kind is a job which indicates which object we want to create. You remember that each kind has its attached behavior. Metadata, here we have a simple name for the job. The specification of the job would be this one. So there's a template, which means that there will be containers derived from it, because the job is basically a concept similar to the replica set that sits above the pod. So it is something that will create a pod for us, but provides additional semantics. So in this case, it's a simple job that only consists of one container. It will restart on failure. It will execute the busybox and basically do the same thing as before, but as a job. And we can also see that now we do have a job. You can see that the completions have been 0, that the duration has been 3 seconds. So let's look into the description of this job. So you can see the namespace, the selector, the labels. We can also see that there is something called parallelism, which suggests that you can do something in parallel. We have completions, which somehow suggest that you can do something a certain number of times. Duration, pod statuses, which somehow suggests that there could be multiple pods involved, which makes sense because of the repetitions and the parallelism. Pods, the usual events, which tells us here there's a linkerd proxy injector which has not been fired, which is unrelated to the job. So we can say that the job is a concept that sits above the pod and gives us additional functionality. So let's have a look at what this could be. Yeah, one thing to mention, this is pretty similar to the replica sets and the deployments. It will be also the same for the stateful sets. Is you can see that here they are automatically labeled, assigned to the job. Here job name, simple job name, and of course you can also query the pods corresponding to particular job. And as you can can imagine, if you run multiple containers in parallel or in a certain sequence, that the number of pods related to the job could be more than one, especially if you're also running other workloads in the namespace. Keep in mind that this automatically assignment of labels will help you to filter if you ever want to get in a debugging session, for example, the pods that are related to a certain resource. So this doesn't apply to jobs only. The labels will look different for other Kubernetes resources, but whenever Kubernetes creates subsequent resources on behalf of you, because you created a higher level object such as a job or replica set or stateful set or deployment, then they will link the resources together. They will do that for you, but they will also do that for their own management, I suppose, so that they will know, that the controller will know what are the resources that are actually belonging to a particular job, to tidy it up at some point or to check on it. So we can have a look at the pods logs as suggested in the tutorial. So let's do that. It's no surprise. Just saying that you can see a simple one-off job from YAML, which is the name of the job, and similar to replica sets, there's a little shuffle string as a suffix that will create a unique name for your particular pod, which somehow makes sense if the template in the job for the container may potentially create multiple containers, as with replica sets. So yeah, the usual commands are available. You can get the jobs, then of course you can also delete the jobs. And of course you can assume that if you delete the job, subsequent or dependent resources such as the pods will be deleted as well. Keep in mind that Kubernetes works with eventual consistency. So if you delete a resource, you tell Kubernetes, I would like to have these resources deleted. It will respond to you, yes, I have acknowledged your desire, but I will do the job later, so to say. This is often very quickly, but for example, if you delete a namespace and there's a lot of resources in there, this can take a lot of time, and it may also be blocking, because something is in there that can't be deleted or whatever reason. So the eventual consistency means that these steps do not happen immediately, but they will be taken care of in the background. So in Kubernetes, one of the problems you may have with more complicated deployments in real-world environments is that at some point a resource that you declared should be modified, created, or deleted will fail to do so in the background, and therefore your subsequent deployment steps or automation or whatever you rely on that will fail. So it is good manners to ensure that if you utter the command to Kubernetes that you also keep track of whether it has worked, because there's a failure rate to everything. If you're as a human deploy, well, you can do that yourself. If you build automation around it, that becomes more relevant. And Kubernetes is basically meant to build automation around it, because as you can see, the way you interact with Kubernetes, with specifying and modifying these YAML files, it's somehow tedious. It's not really user-friendly. Still better than messing with virtual servers, but it's not as convenient, for example, as interacting with the Cloud Foundry, where there's a higher, or let's say where there's a higher comfort in interacting with the platform, because, for example, there's an entity called applications, so you can push your applications. There's an entity for services, so you can create your database. There's an entity to create a connection between the application and the database. So these concepts do not exist in Kubernetes. It's a lower level API that's provided by default, and therefore a bit more complicated to use.